Hello, my name is Giridhev, and today I would like to present about our group project, which is Unsupervised Self-Organizing Map, SOM, Classification and Prediction for Student Application. This is our group G presenting.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hanif Nordin, and this is our member, which is we have Amirul Rashidee bin Muhammad Jasni. Next is Giridhev, and the last one is Muhammad Hanif bin Nordin.
First, I would like to present about introduction. So the self-organizing map, also known as the cohonent map or SOM, is a sort of artificial neural network that was influenced by 1970s biological models of neural systems. It uses an unsupervised learning approach and a competitive learning algorithm to train its network. The neuron or nodes compete to see who will respond or be triggered to a set of inputs, and the winner is the neuron that does so. SOM can be implemented using lateral inhibitory connections, which allow the winner neuron to limit neighboring neuron activity by providing negative feedback. The topographic map is another notion that SOM focuses on. Some neighboring neurons reflect the information stored from an input, and they can interact via short connections. A feature of the input data is a topographic map's output neuron. SOM is used in clustering and mapping or dimensionally reduction techniques to map multidimensional data onto lower dimensional data, making it easier to grasp complex situations. The process of classifying data into appropriate categories so that it can be used to safeguard and use more efficiently is known as data categorization. The classification process at its most basic level makes data easier to identify and retrieve. Data classification entails categorizing information to make it more searchable and trackable. It also removes multiple data duplications, which can save money on storage and backup, while also speeding up the search process.
Hello, my name is Amirul, and this is our R-code example and step-by-step learning and how the analysis is being conducted. Basically, this is our coding. We will use the cohonent library. Here, we import the data and we convert the data into string and we scale the data. Here, as you can see, based on the data summary, we throw out the mean. So the next step is to use the seed 222. We can use any seed. At first, we will set up our grid, which I use 4x4 grid with the topology rectangular. If I use a bigger grid, it will show an empty cluster, and if I use a lower size of grid, the model will have a less cluster, therefore it will learn less and the model will be underfit. Next, we use the SOM function and we put it in the x-axis grid, and the grid we said just now, we use the alpha, which is the height, which is the weight, with 0.05 and 0.01, and the radius or learning rate are as an default. So we just ran it, and here you can see, here is our training progress, which on the right side you can see ups and downs is the mean distance unit of the data into the cluster. It took us less than 100 iteration of learning to get basically the same data. As you can see, from the 43rd until the 90th iteration, we get almost similar data. So here is our mapping of cluster of data. So as you can see, there's data in the cluster, and as I said, we will have 16 clusters since we use 4x4. And now to see what data, what cluster the data belongs to. So the first data belongs to the 11th cluster, which is here, and the second data belongs to the 9th cluster, and the third data belongs to the 7th cluster, and so on. So to see the cluster based on what, it is based on the T attribute, which is GRE, GPA, and rank. Each of the GRE, GPA combination is a very unique combination. So that's for the SOM. And to know how effective it is the SOM, we will split the data into testing and training data by ratio of 70 to 30. Then we will normalize the data again. We set the classification for the training data. Here's the classification for training data. And then we will compare it. So we've produced the confusion table for the testing.
For data analysis, we unsupervised SOM and explanation of finding figures and result. First, we have y-axis is mean distance to closest net, which is here, and the next is x-axis is default iteration for creating this map is 100. As you can see, is from here 0 until 100 iteration. Next, initially the distance is high, but very quickly it fall. You see, from the height peak and then it will quickly fall until here. So that's mean even less iteration we still can get the similar result. Next, for this code plot, first we have each color represent variable in our dataset. Second, which are GRE, the color of GRE is green. For GPA is the peach, and the last one is rank, which is white. Third, there are 16 nodes contain information about those 400 applications and these 3 variables. Next slide. Okay, this is our classification. First is the each value represent the node number to which that application belong. That means 11 here at the first value, start count until 11 from below and left to the right, and then up from figure 6.2. That means as a previous slide, we need to start count here from the left bottom until the right, and then up 1 2 3 4 5 6 7 8 9 10 11 here. Next slide, and so on. And then this is our heat data, which is the 11 value from before is shown as here. M is 0, GRE is 318, and GPA is 3.61, and the last one is rank, which is 3. The number for every attribute from every value that show at page 10, as previous slide lah. And then example like first row, it show the information for the 5 value, which is 11 from page 10. And then for the maps code, here as you can see, V1 until V6 is the nodes 1 until node 16. And then for each node, the file size is based on above number. As you can see from the here, we have 16 nodes. We have 16 nodes. Okay, next. Here, this is a mapping plot. First, it shows how many data points for each node. As you can see here, there is the little dot for each node, and as you can see here, this is the most dot we can have. For example, the red border. Okay. Next, black line is matrix first, which is based on data from data independent variable. Here, this is a black line, which is a matrix 1. And next, red line is matrix 2, which is based on data from dependent variable data. As you can see here, this is a red line for matrix 2. And next, it is content information about either or not student application was accepted. And the last one is, as you can see, from 80 until 100 iteration, there is a stabilized at very low value. Here, as you can see, there is no like a sharp point in this figure. Next slide. For this cost plot, there are 25 nodes here, 5 5 5 5 5, and next is classified into 2 groups, which are the green one where the student were not admitted, and the other one, which is white, is student were admitted. As you can see here, this is the first group, which is green, and the other one is white group, which is student were admitted lah. Next, this is our final result, which is cos x and cos y. This is there are 2 plots with cos x and cos y. Next, cos x is for the independent variable, while cos x is for dependent variable. And then we create a boundary to make clear which are to make clear that there are two clusters we have, which are, you can see, this is first cluster and the next is second cluster, green and white. For the next presentation, I pass to the Giridhev to present the next slide.
As for conclusion, in the last decade, the number of SOM applications in classifications and prediction has increased significantly. SOM is an intriguing technique in this sector because of its capacity to explore and interpret high-dimensional data without making any strict assumptions. By offering a light introduction to self-organizing maps and discussing their qualities, limitations, and applications, it contributes to this growing body of knowledge. Combining the SOM with relevant statistic approaches, heuristic methods, or decision-making tools, it can be concluded appears to be a potential way for broadening the application field to industrial engineering challenges. Understanding the mathematics of self-organizing processes, on the other hand, will continue to be a hot topic of research. So that's all for our group to present today. Thank you.